All right, guys, this is Mr. Ainsworth, and we're going to get into some pre-calculus material here and how to use your identities to prove some things here. All right, and what we want to do is justify each step as we go and use your identity. So what I suggest before you get started here is having your notes side by side, and hopefully you made some note cards on some identities. Hopefully you have them somewhat in your mind because having them on your notes or on a piece of paper is one thing. Having them between your ears is another thing. So you can like see things in your mind. You can visualize and you can see what I see. So I would highly suggest that. If you don't have them memorized, have your notes side by side so you can refer to them at any time. So let's get started. All right. We're going to prove that sine of x divided by 1 plus cosine x plus 1 plus cosine x over sine x is actually equal to 2 cosecant x. All right, so what we're going to do is we're going to set up the proof here. You always have to prove that the left side is equal to the right side. Okay, and obviously that this part right here is the left side. All right, because the equal signs actually separates the two sides. I'm going back to basics here. All right, and we got to prove that all of this on the left is actually equal to the one on the right. So you have to prove that through a sequence of equalities. Okay, so we're going to start off with sine x here. All right, plus one, divided by 1 plus cosine x. All right, plus 1 plus cosine x divided by sine x. All right, that is actually equal to 2 cosine x. So what we're going to do is we're going to put the goal down here. Okay, our goal is to show that it's equal to 2 times, all right, cosecant x. This is our goal. And the only way we can do that is by showing that through a series of equalities, we can get to our end goal. All right. Now, before I do this, I have to mention something. I got to show you what's called the three product rule. This is used a lot. Um, this is not a formal mathematical theorem or principle here. It's just how I combine fractions. So I call it the three product rule, and it's used for adding and subtracting fractions, okay, of different denominators. All right, so for example, what I'm saying is that let's say 3/5 plus 1/2, you can do it through a series of three steps using multiplication, believe it or not, which makes it simple. All right, so I'm going to multiply here 3 times 2. I'm going to add 5 times 1, and then I'm going to divide it by 5 times 2. So when I look at this, I see 6 plus 5 divided by 10. All right, 3 times 2 is 6, plus 5 times 1 is 5, divided by 5 times 2 is 10. All right, so this is step one, that's step two, and this is step three. All right, you always start with the left diagonal here, whether it's addition or subtraction, doesn't matter. And you get 6 plus 5 divided by 10, which is 11 tenths. Now, it also works for subtraction too. All right, so let me show you that. So let's say we have 7/8 minus 1/3. All right, one more time. So I start off with the left diagonal, all right, then the right diagonal, and then the denominators. That's why I call it the three product rule, because you're going to multiply 3 times. Step one, step two, step three, and make sure you always start off with the left diagonal because order is important when it comes to subtraction. All right, so here I see 21 minus 8. All right, 8 times 1 is 8, and then 8 times 3 is 24. And so 21 minus 8 is 13, so I have 13/24. This works for variables too, so if I have, let's say, 2 divided by x minus, let's say, 1/2, I get 4, all right, minus 1 times x, or x, divided by 2x. So it works for variables as well. And this is how I combine expressions real fast. Okay, so let's go ahead and use it. Like right here, I see sine x times sine x, which is sine squared x. And the way you write that is like this, sine squared x, plus, okay, 1 plus cosine times 1 plus cosine, which is 1 plus cosine x squared. Like that, all divided by 1 plus cosine x, all right, times sine of x. Okay, so we got that, and somehow we got to get from here to here. All right, and we got to simplify this, so I got to square the binomial. All right, so what is this equal to? So I've got, let's see the numerator here. I got sine squared x here. When you square a binomial, you multiply it by itself. If you don't know how to do that, you square the first term. Let me take it off to the side. So 1, because I don't know if you guys know this or not. So 1 plus cosine squared means 1 plus cosine x times 1 plus cosine x. That's, if you don't know how to do it mentally, this is what you would do. And you distribute and multiply or use FOIL or the box method, one of the two. And you get 1 times 1, right, which is 1, plus 1 times cosine x, which is cosine x, plus cosine x times 1, which is cosine x. And then cosine times cosine is plus cosine squared x. All right, and what do you get? You get 1 plus 2 cosine x, all right, plus cosine squared x. So this right here, what I just did, all right, gives you this. So I've got 1 plus all of this. So 1 plus 2 cosine x, all right, plus cosine squared x, all divided by the denominator. So 1 plus cosine x times sine x. So now, what does this become? So you want to look and search for identities. I see sine of x or sine squared of x times this cosine squared of x. And guess what? That's an identity right here. That's an identity, and that actually equals to the Pythagorean identity, and that's 1. All right, that's equal to 1 here. All right, if you check your notes, that's the first Pythagorean identity. Make a little note over here. All right, and this is going to be used all the time. Cosine squared x plus sine squared x, all right, is equal to 1. It's an identity. Look in your notes. And so that's 1. So I have 1 actually plus another 1 plus 2 cosine x. So 1 plus 1 plus 2 cosine x all divided by this denominator, which is 1 plus cosine x times sine of x. Well, we got to simplify. So 1 plus 1 is obviously 2, so I get 2 plus 2 cosine x divided by 1 plus cosine of x times sine of x. And then you got to ask, what in the world do you do to get from here to our goal? Well, whenever you see something in common, always factor out the GCF. And I'm talking about right here, the GCF of both of these terms is 2. So we're going to factor out a 2. So this is 2 times something. All right, when you factor out a GCF, you get 2 times 1 plus cosine of x. If that doesn't make sense, just simply distribute it back through. 2 times 1 is 2, and 2 times cosine x is 2 cosine x, all divided by the denominator, so which is 1 plus cosine of x times sine of x. And if you can see closely here, you got something in common. Look right here. That's the same as that, right? And anything divided by itself is 1. So this is equal to 2 times 1, which is 2. So let me see. This is equal to 2. All right, 2 times 1, which is 2, divided by sine of x. All right, which is 2 cosecant of x, because 1 over sine x is the same as cosecant of x. And voila, that's our goal. So I can put this down, guys. I can say, ooh, all right, QED, quod eris demonstratum. All right, that which was to be demonstrated. All right, I demonstrated that the left side is actually equal to the right side through a series of equalities. And by the way, these equal signs are important. If you don't put this in, your proof is not valid. Okay, so make sure you do. All right. All right, let's try another one. So, number 2, we got tangent of x plus cotangent, or excuse me, theta, divided by secant theta times cosecant theta. Ooh, and then we got to show that's actually equal to 1. Holy cow. All right, so here's my proof. Here we go. You got to start off the left side and show it equals to 1, which is the right side. So we got to start off with the left side. So here we go. So tangent of theta, all right, plus cotangent theta, all right, divided by secant theta. Oops, not plus, but times. It's times right here. Times cosecant of theta. What is that equal to? Well, we always write things in terms of sine and cosine. So let me do that. So tangent of theta we know is cosine over sine, or excuse me, I'm sorry, I didn't say that correctly. Sine of theta divided by cosine theta. Plus now, this is reciprocal of that. So cosine theta divided by sine theta. And then secant of theta is 1 over cosine theta times 1 over sine theta. So this is one of the most basic techniques there is in proofs. You want to rewrite all function in terms of sine and cosine. In fact, let me write that down. You want to rewrite, okay, all functions in terms of sine and cosine. All right. If you look back in your notes, we wrote that down. Okay, and again, the second thing I said is that you got to combine fractions because having fractions within fractions is like complicated. All right, so you got to combine the fractiones. All right, now right here I see the three product rule. All right, so we wanna multiply here, that's sine squared. Multiply here, that's cosine squared, and then multiply here, that's cosine times sine. So you want to use the three product rule. So here we go. So in the numerator, I see sine squared plus cosine squared divided by cosine times sine. And then here, this is just a fraction. All right, 1 times 1 is usually 1. And then cosine theta times sine theta. Now I still have a fraction divided by a fraction. And as I said to you before in the lesson here, whenever you divide fractions, you multiply by the reciprocal. So that's a key concept right here. So you want to multiply by the reciprocal. Multiply by the reciprocal. Got to go back to fourth grade, believe it or not. Okay, because that's when you learned it. All right, so this is equal to this whole entire fraction up here, which, by the way, let me show you something here. This is a Pythagorean identity. Right there, that's 1. So this whole thing right here, all right, that's 1. Remember what I said earlier. Over here on the left, cosine squared theta plus sine squared theta equals 1 all the time, no matter what the angle is. All right, it's an identity. That's what identity is all about. It's just no matter what theta is, the angle, it's always equal to 1. All right, so we have 1 divided by, okay, look at that, that's 1. I color coding it right there to help you guys see it. Sine squared theta plus cosine theta equals 1 divided by cosine theta times sine theta times the reciprocal. So I got to invert this bottom fraction here. So cosine theta times sine theta, and I'll put it over 1 just so you can see how I multiply by the reciprocal. And then right there, you can see what's going on. Cosines cancel to 1, sines cancel to 1, and you get 1 times 1 divided by 1, which is 1. Okay, there you go. And that is how the game is played, my friends, okay? There we go. Let's do another one. And by the way, if I go too fast, this is a video, right? And because it's a video, hit the little rewind button and rewind it, all right, if you want to listen to it again if I go too fast. All right, everybody's different, so go at your own speed because this is a video, so use it effectively. Okay, so I got to prove here on this next one that 1 over sine x divided by cosine x is equal to, all right, the right-hand side, which is cosine x, all right, divided by 1 plus sine of x. All right, you got to prove that the left side equals the right side, all right, through a series of equalities. So make sure you put in equal signs, otherwise it will not be valid. Okay, now on this one here, notice that 1 minus sine x kind of looks like 1 plus cosine x. They're actually conjugates of one another. One's a difference, one's a sum, and that's a clue. So let me show you a mathematical trick here that I learned back when I was young. All right, whenever one's a difference and one's a sum, you multiply by the conjugate in the form of 1, okay? That's this right here. So I'm going to multiply by the conjugate in the form of 1. All right, multiplying by 1 doesn't change the expression at all. Okay, so it's still the same expression. It's just going to change the look of it, okay? All right, anything divided by itself is 1. So this is called a form of 1. All right, so it's legal, okay? Now when you multiply these right here, use, all right, distributive property or FOIL, whatever you want to, or the box method or whatever you want to do. All right, so let's multiply. 1 times 1 is 1. 1 times sine x is sine x. Negative sine x times 1 is negative sine x. And then negative sine x times sine x is negative sine squared x. All right, and then divided by the denominator, which is cosine times 1 plus sine x. I'm not going to distribute there. Leave it in factored form. Now look closely here. This right here, this cancels to 0. All right, sine x minus sine x is usually 0. And that leaves me with 1 minus sine squared x, all right, divided by the denominator, which is cosine x times 1 plus sine x. All right, now this right here is screaming at you. This is a Pythagorean identity. So let me write it over here. So, all right, this is our main identity. Cosine squared x plus sine squared x equals 1, which means that if I subtract sine x, I get cosine squared x is equal to 1 minus sine squared x. This is the variation of it. So the numerator here is nothing more than just cosine squared x. So let's write it as such. So this is cosine squared x. Okay, let me color code this. These are equivalent. It's an identity. Divided by cosine x, all right, times 1 plus sine x. Okay, now if you don't see that the cosine x is cancel, you have to understand that cosine squared x is cosine x divided by cosine x divided by cosine x times 1 plus sine x. Obviously, anything divided by itself is 1 right here, and then we get our goal, and then we're done. There we go. Quad aorist demonstratum. Okay, this is the same. All right, you see it right here. All right, and that is how the game is played. So let's do it again. Now, if you're working with me online and you're trying this, and you think you got it, go ahead and pause the video and try this one and be smart about it. Try it and then check it after you're done. Okay, just don't copy. Okay, that doesn't really help you any. All right, so give it a shot. And if you need my help, obviously run the video. But if you don't, just go for it. All right, because that's where the learning occurs. So we got to show that this is equal to tangent x. All right, that's the right-hand side. You got to change here and rewrite everything in terms of sine and cosine as I stated up here in number 2. Okay, very, very simple procedure. So this is going to be 1 plus sine of x divided by, excuse me, I didn't say it correctly. 1 plus sine of x over cosine of x, all divided by 1 plus the reciprocal of that, which is cosine x over sine x. Remember, tangent is sine of x over cosine x. Cotangent's reciprocal, so you just reciprocate it. Now, we got to get somehow to tangent of x. So notice that we have fractions within fractions, and you got to combine fractions. Now, this is a 1, and I can rewrite 1 in any form I want, and I need a common denominator of cosine x. So keep in mind that 1 is the same as cosine x divided by cosine x. I'm going to use that here. And then I'm also going to use 1 equals sine of x divided by sine of x. And I'm going to use it down below because I got a denominator of sine x. So I'm just going to rewrite the fraction. So I'm going to rewrite 1 as cosine of x divided by cosine of x plus the second fraction, which is sine of x divided by cosine x. So I have common denominators. And then down here below, I got 1, but I'm going to use sine of x over sine of x because I got to have the same denominators, right? Going back to 4th grade. Plus cosine of x divided by sine of x. Now it looks complicated, but you got to think simple here. The denominator is cosine x. So you just read it from left to right. Cosine x plus sine of x, all divided by cosine x. Cosine x plus sine of x, all right, all divided by cosine of x. Now denominator, left to right, sine of x plus cosine of x divided by sine x. So sine of x plus cosine of x divided by sine x. Okay, now this is not a Pythagorean identity because they're not squared. All right, so now I have to multiply by the reciprocal. So I take the top fraction here, which is cosine x plus sine of x divided by cosine of x, multiply by the reciprocal of this guy, which is sine of x divided by sine of x plus cosine of x, and watch what happens. All right, these two expressions are the same. All right, and anything divided by itself is 1, which gives me, well, look at this right here. Sine of x divided by cosine of x which happens to be tangent, and now you're done. Okay, okie dokie, that's proof number 4. I didn't have to work backwards on any of them so far because I kind of figured out how to do it. But some of you guys, when you try this in class, had to do that, which is good. All right, sometimes you go work forward all the way through, sometimes you got to work backwards. All right, now number 5. How do you do number 5? Number 5 is kind of unique because it involves the cofunction uh, identities. Okay, so what do you need to know for number 5? You need to know, okay, so I'm going to say recall here, and again, use your notes. All right, use the notas. Okay, that sign of negative x, think I used negative theta in class, but it's the same thing, is equal to negative sine theta, or sine x, excuse me, and then cosine of negative x is the same as cosine x. These are called the reduction identities. So reduction identities. And you could see your notes because we went over them, and you guys are supposed to make note cards on them. All right, so let's use this. So I'm going to rewrite this so it makes a little bit more sense. So I got to show that sine squared of negative x, all right, plus cosine squared of negative x, I have to show that it actually equals 1. Okay, so here we go. So I'm going to rewrite this to make it a little bit more sense. So sine of negative x squared is the same thing. So when you square sine of negative x, you can rewrite it this way. The notation on the top is actually this shorthand way to use this because it doesn't use 2 sets of parentheses. But what you're really doing here is you're taking sine of negative x and you're squaring it. And on the second one, you're taking cosine of negative x and you're squaring it. Okay? Now let's make the substitution. So sine of negative x equals negative sine of x. So I need to substitute that in. Okay, negative sine x. We'll square it here in a minute. And then on the second one, okay, well, let me go back to the first one. These two things are equals. That's why I can substitute in. And then this second one here, this cosine of negative x, well, that's just the same as cosine x. So I'm just going to write cosine x here and square it. And then I'm going to square these things. And when you square a negative right here, you get a positive. All right, so square of negative 1, as you can think of that as negative 1, is 1. Square root of sine x is sine squared x, when you write it the more traditional way. And then when you square cosine x, you get cosine squared x. That's how you traditionally write it. And guess what? That's equal to 1. All right, because that's the Pythagorean identity. All right, let me write it again. Cosine squared x or theta plus sine squared theta equals 1. It doesn't matter whether you use x or theta, it's the same thing. All right, x and theta just represent an angle. So it's true for all theta, it's true for all x, and that's why the Pythagorean identity always equals 1. And there we go. Now, a similar thing's going to happen over here. So if you understand number 5, then number 6 is doable. I'm going to do the same thing. So my proof here I'm going to take sine squared of negative x, all right, minus cosine squared of negative x, divided by sine of negative x. I'm just rewriting it. Minus cosine of negative x. And I'm going to show it's equal to down here. I'm going to show let's put it way down here. I'm going to show that it's equal to cosine of x. All right, minus sine of x. Okay, that's my goal. All right, so here we go. I'm going to rewrite it like I did before. So this means, the numerator here, it means take sine of a negative x and square it. The second one means the same thing, but with cosine. So take cosine of negative x and square it. Okay, let me, and the denominator, well, let's simplify it, okay? Sine of negative x is negative sine x. Cosine of negative x is just cosine of x. So again, I replace this with this, and I replace this with this, all right? Because they're identities, they're equal. And now you simplify. All right, I got to do the same thing up here, so I'm not done yet. So I got to replace sine of negative x with negative sine x. I've got to replace cosine of negative x with cosine of x. And then I already simplified the denominator, so I'm just going to rewrite it. And now I'm going to square it. Now, when you square this, you get sine of negative, you get sine squared of x, excuse me. Square cosine, you get cosine squared x. And then over here, I'm going to, hmm, hmm. You know what I'm gonna do? I'm just gonna factor out the negative. They're both negative, so I'm gonna factor out the negative. And what I notice is that sine x plus cosine x is actually a factor from above. So this up here, I'm gonna make a little note here. This is called a difference of squares. All right, so if you ever see a squared minus b squared, that's always equal to a plus b times a minus b. This is what you learned in Algebra 1. It's called a difference of squares. Something squared minus something squared is called a difference of squares. So what I need to do is factor it. Okay, so I'm going to squeeze it in here. So up top, I get sine x minus cosine of x times sine x plus cosine x, all divided by the denominator, which is negative times the quantity sine x plus cosine of x. And if you look closely, these cancel nicely. Okay, all of that cancels with all of that. And then let me rewrite this here. Let me squeeze this down. So what I get is this all divided by negative 1. In other words, I get negative 1 times the sine of x. Let me write that a little bit cleaner. There we go. All right, minus cosine of x. And if I distribute through the negative, I get negative sine x plus cosine of x. And if I just switch the order, I get what I'm trying to achieve. Okay, cosine x minus sine x. All right, and now I'm done because that, my friends, is the right-hand side. So it takes a lot of different skills. You have to be good at Algebra 1. You have to know how to factor a difference of squares. You have to get good at notation because the notation is what screws people up on examples 5 and 6. And I'm talking about sine squared of negative x versus sine of negative x squared. They mean the same thing, okay? And once you get the hang of that, it's easy. But in the beginning, when you first see this material right here, it's difficult because of just the notation. And again, once you see it, you'll probably be good to go. All right, let's try another one. All right, number 7 and 8, last two. All right, so let's give these a shot. All right, these may not be the easiest things, so let's go for it. Okay, so here's the proof. Let's set it up. Okay, let's set up the left side. And then way down here at the bottom, let's put down our goal. So secant x minus tangent of x squared. So how do you get from here to here? How do you get from the left side to the right side? This is a good one where you might want to start working backwards. Okay, I'm going to make a little note here. Work backwards. Now, I worked with some people in class on this one, and they did it, and they actually made it happen completely backwards. It was pretty cool to watch them do this. So I'm going to do the same thing because you really don't know what to do. What do you do with the left side here to get this? And who knows, right? So let's rewrite it. So this is the quantity of 1 plus cosine of x minus sine of x divided by cosine of x. All right, quantity squared. So let's combine fractions. Let's work backwards again. All right, so let's use the three product rule here. So we have cosine of x minus cosine times sine. So cosine x times sine x, all divided by cosine times cosine, which is cosine squared of x. Oh, wait, I'm sorry. Scratch what I just said. They have common denominators. Silly me. We don't need to do that. I'm complicating things. Just subtract. Okay, so 1 minus sine of x divided by cosine of x. They have a common denominator. Silly. Okay, sorry. Okay, we're going to continue working backwards here. All right. And then you got to square the numerator and square the denominator. So let's do that. So here we go. Let's square the numerator. Now, when you square the numerator, it's 1 minus sine of x times 1 minus sine of x. I don't know if you guys know how to square a binomial in your head, so just write it out. Just square it, which means you multiply by itself, divided by cosine squared x. You got to square the denominator. Now, working backwards again, you're working backwards here. You got to multiply out. So let's multiply. So 1 minus sine of x minus sine of x, just use distributive property, plus sine squared of x, all divided by cosine squared of x. So what's happening here? So, so, so let's work backwards again. So this is 1 minus 2 sine of x plus sine squared of x, all divided by cosine squared of x. Just simplifying here, all I did was rewrite this as this, okay? Minus 1 minus sine x is a minus 2 sine x. And then the question is, what do you do? What do you do? So, what do you do? So, let's see, what should we do here? I'm going to use a trick that I used before. So, I'm going to use a conjugate. So, let's see what happens when we multiply by the conjugate here and get this quadratic here. Okay, so let's multiply. Let's take 1 minus sine x here, divided by 1 plus sine x, and let's multiply by conjugate and see what happens. So 1 minus sine of x divided by 1 minus sine of x. You saw me do this in a previous problem. All right, so let's see what we get. Okay, so let's insert a step here. So let's multiply up top. You get, oh my gosh, we just did this earlier. It's the same as this. Ah, okay, so this is the same. So 1 minus 2 sine of x, all right, minus, or excuse me, plus sine squared of x, all divided by this, all right, and this is 1, you got to multiply here. So 1 minus sine x, I'm multiplying the binomials down below, plus sine x, all right, minus sine squared x. Ooh, what do we get? Okay, now notice what happens here. These terms cancel out, and I get 1 minus sine squared x. And note, all right, 1 minus sine squared x, which is in the denominator here. I want you to look right here. 1 minus sine squared x, that's this right here. That equals, all right, cosine squared x. It's an identity. All right, and guess what? This equals this. I'll put an equal sign there. All right, and the top, well, they're the same. All right, so I just finished the proof. So I worked backwards, I worked a little bit of forwards, I met in the middle here, and I get a statement or a sequence of steps that are all equal. So therefore the left side, all right, this is the left side, all right, equals the right side, all right, and then I just proved the identity. Okay, continuing. Okay, so here we go. We got this complicated expression here. So 1 minus cosine squared x divided by, no, that's not correct. Let me start over. 1 minus the fraction cosine squared x, all right, divided by 1 plus sine x. And we have to show that that's equal to just sine x. Holy cow, this is simple. Okay, well, I mean, the result is simple. The process is not. So you got to combine fractions right here. So we need a common denominator. So I'm just going to rewrite 1, all right, as 1 plus sine x over 1 plus sine x. Okay, you got to remember, you can write 1 in any form you want. So this is going to be 1 plus sine of x divided by itself. That's the same thing as 1. What's going on with my pen right here? Sorry. So 1 plus sine of x. All right, so what I just did right there is I took 1 and I rewrote it. All right, anytime you divide anything by itself, you get 1. So this is equal to right here 1 plus sine x over 1 plus sine x minus the second fraction here, which is cosine squared x divided by 1 plus sine x. Notice they have the same denominators now. All right, now I can write it as one fraction. The denominator is 1 plus sine x. Whenever you add fractions, the denominator does not change, going back to fourth grade. Okay, so they look different now because we're in pre-calc, but whenever you add or subtract fractions, the denominators do not change. And then from left to right, okay, left to right, whoops, I meant to do this right here. Left to right, look for, so I got 1 plus sine x minus cosine squared x. So I'm just going to write that. 1 plus sine x minus cosine squared x. And then what is this equal to? Well, we got to rewrite something here. I'm going to switch the order. I'm going to group up these terms, 1 and minus cosine squared x, because that is an identity. All right. So 1 minus cosine squared x. And then I've got this plus sine x hanging around. And then I've got the denominator 1 plus sine squared x. Excuse me, 1 plus sine x. Well, this is an identity. Okay, 1 minus cosine squared x is equal to sine squared x. So this part right here, let me highlight it. Let me choose a different color. All right, this part here is equal to just sine squared x. So sine squared x here plus sine x, all right, divided by 1 plus sine x. And then you're going to wonder, how do you get from here to our goal? Our goal is down here. All right, we want to set it equal to, or show it's equal to sine x. And notice whenever they have a common factor here, factor out. All right, always factor out the common factor. It's called factoring out the GCF, which is another Algebra 1 concept. Factor out GCF. We're using a lot of Algebra 1 here. All right, so we factor out sine x, and I get sine x plus 1. If you don't understand that, just distribute it back through and it's equal. All right, divided by 1 plus sine x. And you'll notice, you look carefully here, that these are the same. All right, sine x plus 1 is the same as 1 plus sine x, and so if you divide them, you get 1. And then all you have left over is sine x, and you are done. Okay, quod eris demonstratum. All right, that which was to be demonstrated. And that is it, my friends. You pre-calc meatballs, you. Okay, all right. Now listen, we have something unprecedented in history going on, which is the school is closed because of a coronavirus. And that's one of the reasons why I produce this video, because I will not see you on Monday for 3 weeks. So I'm going to be sending you online tutorials, all right, through videos. And so use them to your advantage. In my opinion, you can learn just as much from a video as with me in person, because it's the same thing, it's just virtual, okay? And what's cool about a video is that you could pause, play, and rewind and watch as much as you want and practice, all right? I've had many students that have been absent for weeks at a time due to illness go through my videos and get through it just fine. So go ahead and use them to your advantage, and I will see you in my next lesson, whether it's in class or online. I'll see you soon. It's Mr. Ainsworth. See ya. Bye-bye.